Okay, we're continuing on with section 1.3, and I am so sorry that I forgot to turn off the phone. And so I abruptly finished talking about a blind, um, double blind test for um, any kind of investigation in statistics, because we're designing in this section. And I warned you that there was going to be a lot of information. Now understand that in this information, it is exposure. It makes sense of what you hear and see during your adult life. I talked about double blind, and we said the subjects don't know whether he or she is receiving the treatment or the placebo, and the experimenter does not know whether he or she is administering the treatment or placebo. This allows no reference by the experimenter. It's usually a technician. The subject is receiving a placebo or the drug. And you can see how important that would be. We all give body language on everything. People understand immediately if you like them or don't like them. Now, here we have randomness. And I wrote in here from what I've learned and gleaned, uh, when the subjects are assigned to different groups through the process of random selection. The logic behind the randomness is the chance as a way to create two groups that are similar. So you take a pool of subjects and pull out numbers. Now, the way to do this is usually a program, and it does it for you so that there's always that capability. Now, in this book, they referred to a simple random sample as the standard. Instead of saying randomness, they will say simple random sample. And that's because this is more explicit on the process of the strength of being a random sample. So what the book says a random sample is, of n subject is selected in such a way that every possible sample of the same size n has the same chance of being chosen. In other words, there is no way that if you take the same pool and select that somebody is omitted, and there is it removes the chance of bias. Okay. Um, okay, now here's what I was referring to about this book. A simple random sample is often called a random sample, but strictly speaking, a random sample has a weaker requirement that all members of the population have and the same chance of being selected. That distinction is not so important in this text. In other words, a random is used, but simple random sample is much more believable or has strength. So let's do an example. All right, here we go. In a double blind experiment. Okay, so we know nobody knows who's getting what except the people running. To test the effectiveness of a new drug, medication, um, as a treatment for lower back pain. So then we have our cardinal number 1,643 patients. These are our subjects, are randomly assigned to one of three groups. The first group is 547 subjects, placebo. The group two is 550 subjects, is 550 were the group given pills with the new medication taken at regular intervals. All right, and group three is 546 subjects. The in the group given pills with the new medication to be taken when needed. So where it is used as a PRN, the same new medication by the subject when they need it. All right. So we're studying here the effects of pain control by the patient in a regular dosage and a placebo, covering all three conditions that could happen. So, what does it mean to say that the experiment was double blind? Subjects and the um, experimenter have no knowledge of what group they are in. And therefore, what do we know about that? Therefore, the experiment uh, gave outcomes are not affected by prior knowledge. So, in this case, until the end of the experiment, would they understand what's going on? So, here we have another system of experiments, of testing, designing, and that's a systematic sample. Selecting some starting point and then selecting every case. That means um, a chosen number. Uh, element in the population. of whatever we're studying. And they do cars. I worked at a air conditioner factory, and we tested every 10th unit produced in the plant. Did we catch all of the errors? No, we didn't catch all errors, but we identified if there was an error, what type it was. And and the reason we took each 10th is because daily we produced 50 units, so we checked 5, which is a doable amount in that condition. So then we have another form of um, sampling, and that's a convenience sample. Use data that are very easy to get. This is not always good, but can give good results. So in this one, you might have to do more data collection to make sure that you get a sound survey of whatever it is you're observing or testing. Now, this one's interesting, and that has to do with stratified. Stratified is subdivide the population to at least 2 different subgroups so that the subjects within the same subgroup share the same characteristics. Then draw a sample from each subgroup for the stratum. Um, and in this one, it has to do with if you're testing drug applications by gender, age, or ethnicity. So this one is you now that the picture the book gave was about men and women, and men have certain criteria that are generally had in a male, and women have another. This is getting convoluted now as we change our concepts of gender. Cluster samples. That is when you divide the population area into sectors. This is done by pollsters. That is how people argue about what district you're in, because this is naturally divided by income. Naturally divided by income. So clusters are very important to find all uh, possible differences, which gives you a better picture of what we do. So here it says, then randomly select some of these clusters and choose all the members from those selected clusters. Um, like I said, pollsters do this to figure out how the politics are or needs are by surveys usually. So if we wanted to do a survey on homeless and the criteria of the homeless, well, then we would study the area near our downtown because that's where they receive assistance and can find shelter. And that's how we came about with that consideration. So now we're going to do some examples of what type of sampling is used: random, systematic, convenience, stratified, or cluster. So we're reading for content and determining what are they trying to assess in the sampling process. The researcher selects every 982nd social security number and surveys the corresponding person. Well, that one's very easy. It is systematic. Use of a specific number. Selection. All right. That one wasn't hard. To determine a customer's opinion of their in-flight service, Continental Airlines randomly selects 40 flights during a certain week and surveys all the passengers. All right, so that is a cluster. And the reason is all passengers in that flight. So they're a grouping that has self-selected to fly at that particular time, and they're choosing 40 flights during that same period of time. Cluster. Even though it says randomly, don't be, uh, make sure that the fact that randomly is a different concept about the cluster of people that they choose. All of the passengers on the flight that was randomly selected. Cluster. All right, learning. A large company wants to administer a satisfaction survey to its current customer. Using their customer database, the company randomly selects 60 customers and asks them about their level of satisfaction for the company. This one definitely is random. It's individual selection from a database. All right. Now here's our last one. To determine her heart rate, Brittany divides up her day, sorry about that typo, into three parts: morning, afternoon, and evening. And then she measures her heartbeat rate two randomly selected times during the day, that part of the day. And that is stratified. Each one is a grouping, and then selection of time per each category is done so that she gets a good cross section of what is happening. So this is a chart And this is beyond the basic design of experiments and collecting sample data. In observation studies, there are types of observational studies identified in this textbook, and the need to fully understand these. The chart from the textbook clearly explains the differences along the three types named. So here I have it. All right, let me put it a little bit large so nobody has to squint on this video. In an observational, we have choices from past period of time, one period in time. So this says retrospect, if I could speak, right? Retrospective or case control study is to go back in time to collected data over the past period. And this is usually done like in a doctor's office. And in retrospective, they can gauge what is most visited during what period of time. And from that, they can draw data. And they do that as they study COVID. It's always in the past, what has happened in certain periods of time. And each clinic turns in their findings. One point in time is a cross-section study. So they pick a specific time to observe outcomes, whether it be a specific time in um, stop signs versus a signal light in traffic. This is a one point in time. Well, what point of time would be of interest? Well, of course, it's between 7 or I should say 6:30 to 7:30 as people drive to work, or it could be at 5 o'clock to 6 o'clock in the afternoon when people are going home to study the concerns of traffic and control of flow. Control of flow. What the what the what is a company? Okay. What our street manager does is keep a tab of the accidents at particular points at what time they occur, and therefore be able to study that time management of that flow of traffic. And then forward in time. Now, this one I thought was beyond my scope in considering. It is the longitudinal and cohort study. Go forward in time and observe groups sharing common factors such as smokers and non-smokers. Okay, now that one gave me a specific example so that they can catalog what has occurred and what kind of ailments happen uh, from a smoker versus a non-smoker. All right. So here are the definitions given by the textbook as well as the chart. But I thought the chart was much more conducive to putting it in a form that can give you an idea of all of the observational groupings that can happen. So in experiments, the need is to ensure that all experiments are completely randomized experiment design. To this criteria, there are these designs, and these are pictures as well. Completely randomized experiment means that you have treatment and placebo. Uh, this one is randomized block design, and we spoke a little bit about that and the fact that we have women and men who each have particular traits and and sensitivity to subjects. Within the last 10 years, I think it might be the last 12 years, that the researchers found out that heart attack uh, heart attacks in women have different signs than heart attacks in men. And that helped all of the emergency care people recognize that the woman was experiencing a heart attack. and that was a breakthrough in block study of a randomized group. And then we have the matched pair. And that matched pair in an experiment has to do with the before and after. And the doctor is probably the best at the matched. In other words, the doctor will prescribe a medication and insist you come back so that he can put on his notes if it was effective or not. And this is part of that trial and error in matching certain medicines to treatment. So we have some examples here that we want to look at as we read this lesson. And I'm going to stop right here and do the example to give you a break to, regarding the information that we've discussed. Thank you for listening.